Okay, today we will be identifying functions. The objective will be I can identify functions using tables, graphs, maps, and ordered pairs. So the definition of a function is each element of the domain is paired with exactly one element of the range. And so I want to remind you that the domain are your x values and the range is your y values. In just a little bit simpler terms, the way to think about this is no repeating x values. So if no x's repeat in your relation, then it's definitely a function. Okay, so we're going to look at ordered pairs first, and we're going to decide whether the given relation is a function or not a function. So when I'm given an ordered pair, again, no repeating x values. I just want to look at my x values. The y's do not matter. So I go through and I underline all my x values. I double check, okay, do any repeat? No, they don't. So that makes it a function. So we're just going to write function. Number 2, it says 5, 4, 5, and 3. And so I see my 2 5s here. And so that goes back to no repeating x values allowed. So this is not a function. Okay, so now we're going to take a look at tables and still do the same thing, decide whether it's a function or not a function. And so you focus on your x values. You have 0, 2, 4, 6, and 8. And all of those are paired with exactly one y. We have no repeating x values, so that is a function. And the second table, number 4, I have -4, -2, 3, and 3. So that means 3 is paired with -3 and -4. So since I repeat the x values, this is not a function. Running out of room. Okay, so I love graphs because we're not necessarily going to look, so the same requirement, no repeating x values, but there we have what we call a vertical line test. And all that means is you take a vertical line. So I'm going to grab a vertical line. Let's see here. I'm just going to draw up a vertical line. And I can take that vertical line, and if it never touches 2 points on the graph at a time, then it is a function. So I can slide this vertical line anywhere on here, and it is only touching my graph at 1 point. So for instance, right here, it's touching it exactly 1 point. If I grab it again and I slide it anywhere, it's still only touching at exactly 1 point. It never touches the quadratic function more than once. So that is a function. That means it does not have repeating x values. Okay, so here's another graph where I'm going to decide whether it is a function or not. And again, I'm just going to use my vertical line test because it's my favorite test when I have a graph. So that way I don't have to think about, well, are my x values repeating or not? Well, if you see here, if I put this red vertical line into the graph, it's going to touch the graph right here and right here. And so that would mean those x values are repeated. And so that's why we're able to use the vertical line test. And so this is not a function since we have those repeated values. All right, and so the last relation we're going to look at, or last way to represent a relation, is the mapping. And so we're going to do the same exact thing here and decide whether it's a function or not a function. And so my x's are on this side, or my domain. So on number 7 here, I want you to notice that we're still checking to see if x values repeat. And so when you're looking at this map, I want you to notice this -1 is pointing to 0 and 1. So if you were to write those as ordered pairs, that would be -1, 0 and -1, 1. And so since we have those repeating x values, that is not a function. Okay, so let's look at number 8. We have our domain, or our x values on our left, our range on our y, our range or our y on our right, sorry. And so I'm going to check my arrows. This 3, I go 3 to 10, 7 to 4, 8 to 6. So there's no repeating x values. Every element of the domain has exactly one y. And so that makes it a function. Okay, now you're going to go ahead and try these two on your own and bring those with you.